So we're going to do the Nolan-Ryan program together. It uses one-dimensional arrays. Okay, so we're going to do some one-dimensional array processing stuff. So we need to grab our input file. So what you need to do after you log into the Blackboard shell is scroll down and look for a folder called Program Examples. Look in Program Examples. Go down to one-dimensional arrays. Click on that. And scroll all the way down to Nolan-Ryan input. Okay, and we're going to do this from scratch. I know there's a version there that says not complete, but we're going to do all this from scratch. Click on Nolan-Ryan input file. Okay, and so this is going to be our input. So we need to grab this. So you'll probably have to do a copy and paste. So highlight it all, copy it, and paste it inside of your text editor or compiler editor window. Do a new file. Most of you are probably using dev C++, so you can just do file and new source file and then paste it in there. And I'm going to save this as Ryan_input.txt. So let me kind of do that. I've been using that code blocks compiler, but again, dev C++ works just fine. So I'm going to do a new empty file here. And I'm going to copy and paste that. So I right-clicked and chose copy, or I can do Control-C to copy. And then you can do Control-V to paste if you need to, or you can just right-click and... Oh, maybe I can't. No, I'll do Control. It's probably up here. Yes. Or you can just do Control-V to paste. And I said I'm going to save this, so I'm going to make sure I know where I'm saving it. This is just the compiler window, is what this is. You can do it in Notepad. You can copy and paste it using Notepad as well. Just make sure you know where you're saving it, because your source code file will need to be in the same folder. So let me see here. So I'm going to create a new folder here. And I'll just name this Ryan program. And I'm going to save this. I'm going to change this to all files, or if there's an option for that, all files. And I'm going to save this with double quotes around the name, Ryan_input.txt. That's what I'm going to name it as. Ryan_input.txt. So do you guys know who Nolan Ryan is? He's still alive. He's not... Some of you do, right? Some of you might not know. Some you might be before some of your time. So Nolan Ryan is one of the greatest baseball pitchers ever. He holds the record for the most strikeouts thrown in a career, and it's not even close. I was looking it up yesterday. Like the next person on the all-time strikeouts list, I think is Randy Johnson, and he's like almost 1,000 strikeouts back. So I mean, it's not even close. I don't know. I can't foresee anybody passing his strikeout record anytime soon. But you never know. I'm not sure who it would be though. So anyway, he pitched for a long time. That's another impressive thing about his career. I have 26 seasons worth of data here, and there was one season, if I remember correctly, that I didn't include. He didn't really have much data. I can't remember if it might have been first his before his first season. I can't remember, but there really wasn't a whole lot there to include, so I didn't include it. But anyway, this is most of his season, and so what we have here on our info file, every line is a different year of his baseball career, of his baseball pitching career, and the first number on every line is the number of games that he won that year, okay? And so that's his official number of wins, right? Baseball has all kinds of rules for what pitchers get the win and who gets the loss, and then there's no decisions that factor in, right? So you could be a starting pitcher and get a no decision. That just means that you weren't ahead or behind when you left the game, that type of thing. But anyway, so this is his number of wins for that year, and then there's a space, and then that's the number of losses for the year. So his first year he had 6 wins, 9 losses. Then the next number is his earned run average, or ERA, right? So and there's rules for calculating that as well. But basically what that is, that's the average number of runs that he would give up, right? And so a low ERA is good, right? So those are good ERAs, in the 3s and stuff. Those are really good, right? And then the next number is the number of strikeouts that he threw that year, that season, okay? And then the last thing on every line is what team he played for that year. So Nolan Ryan's kind of interesting. He played for several different teams throughout his long career. He started off with the Mets, then he played for the Angels some, and then most of his career after that, after that was with Texas teams. So he played with the Houston Astros for a number of years, and then he ended his career with the Texas Rangers. I actually saw him pitch. What's funny is I never actually saw him pitch for the Rangers. He was never the starter that all the Ranger games that I happened to go to during that time period. But I did see him pitch for the Astros when I was a little kid. Yeah, we went to the Astrodome one time on a family vacation, and he was pitching that game. Of course, I was a little kid. I didn't really know who Nolan Ryan was at the time. But anyway, and he's still around. He was involved with those Texas Rangers teams that went to the World Series, back not too long ago. Was that around 2010, 2011, that time period? And he was like I can't remember what his official position was, but he was involved in the team somehow. And you would see him on TV, and he'd be sitting up in one of the boxes with George W. Bush, right, at the World Series games. George W. Bush had also been involved with the Texas Rangers baseball team back in the early 90s and stuff, I think. So anyway, so that's the data file that we are going to be working with. Yes. Yeah, let me look at it. Okay, so let's see what we're doing here. So right now, we're learning about one-dimensional arrays, right? And so there's a lot of data here. And so here at the beginning, I just want to focus on his strikeouts, because that's what he's really known for. And then after we kind of get that going, we can take it and expand it to include his wins, losses, ERA, and team names. Okay, so we were learning about arrays, one-dimensional arrays last week, right? And so what we could do here, we could have like a one-dimensional array to keep track of his strikeouts, right? So there's 26 years, right? Oh, that's horrible. Let me try that again. And so we could name this array something like strikeout. Right? And we need space for 26 things. So remember how it works. Each one of these will have an index, right? And they start at 0. So the last one will have an index of 25. Right? So that's kind of what it's going to look like. So I want to show you how to do some common array processing things, common one-dimensional array processing things. Okay? And eventually we'll come back and we'll have other arrays for all the other things too. Okay? So some common things that we might want to do here, we might want to, obviously we need to input and output, right? So I'll show you how to do that, obviously.
Wait a minute, I'm missing, I only have 25.
I don't know. You should have 26 years. So you might want to go back and double check and make sure you got the last one. So we're going to input and output. I also want to show you how to do some things like how to add them all up. So how to find the sum, and along with the sum we can find the average. Right? So how to find the sum and the average of a one-dimensional array. Also, other common things to do is finding the largest and the smallest value in the array. So we're going to find the high and the low values. And as an alternative way of kind of finding highs and lows, you could also, instead of keeping track of the high and low values, you can keep track of the index of where the high and the low is, and there's some advantages to doing that. So I'll show you that version as well. So that'd be like the high index and the low index. Remember, the index is just, the position, what position it is in there. So those are the things that we're going to focus on today. How to do those things. And also how to use functions to do all these things. All right. So let's go ahead and create a new source code file. So if you're in Dev C++, you can just go to File and New Source File. Here in Code Blocks, I'm going to do a new project, new console application project. I have to get my folders correct. So I'm going to name this Nolan Ryan with no spaces in there. You can leave it open if you want to, the text file. So let me see all my stuff. I think I need to move my input file in here now. Just make sure that your input file and your source code file are in the same place. Yeah, I kind of messed that up. So I'm going to move this back over here. When you create a project in Code Blocks, it creates a folder for it. So I just want to make sure they're in the same folder. All right, so I've got that handy. All right, so let's go ahead and put some comments in there. I'm going to take out that hello world line. So I'm going to put a block of comments at the top, like we usually do. So I'm going to put something like, we'll keep it somewhat short. This is the Nolan Ryan stats program. So I'll just put something like this. Nolan Ryan, this program will use one-dimensional arrays to analyze some of Nolan Ryan's pitching stats. That's good enough. All right, and so let's do our include files, our header files. So we need IOStream for our basic input and output. And then I need fstream because we're going to use input and output files. We'll probably end up needing IOmanip for things like set width and set precision for output formatting. And we'll probably end up needing string because the team name is a string, so eventually we'll need that. So I'm going to go ahead and put it. And then you have your using namespace line there. And then after you're using namespace line, that's where we're going to put constants. So I'm going to say declare a constant. Declare constants. And so we said that he has 26 years in his career in his input, right? And so we are going to, instead of hard coding the number 26 in all of these loops and stuff that we're going to use in this program, I'm going to set up a constant. And set the size to 26, and we can just use that constant, just in case. You never know. He might decide to come out of retirement and pitch again for the Rangers or something. I'm not sure how old Nolan Ryan is now, but he's getting on up there. But
That's like something you'd wish for.
Oh, it would be cool. But yeah, let's see here. Okay, so how do we do that? So we say const, and then num years is what I'm going to say. We're going to keep this in integer. So const int, and then num years is equal to 26, like that. And then our function prototypes are going to go here after we add them. Function prototypes. All right, so get that much in there, and then go ahead and compile it and run it. Make sure that much should work. It's not going to do anything interesting, but at least we'll know that we have a good starting point and we don't have any errors. I'm good to go. Are we good? So right now I said we're just going to focus on the strikeout array. So that's the only one I'm going to declare at this point. I'm going to go down to my main function. And there inside of main, I'm going to say declarations. And so I'm going to have the strikeout array. So do you remember how to declare a one-dimensional array? So you put the data type just like a variable. All these are integers, right? His number of strikeouts that he threw. He didn't throw like half a strikeout or something like that. So we're gonna say int, and then the name of it, strikeout. So I'm gonna write it like that, strikeout, and then the size. So there's 26 of these, right? But I'm gonna use my constant that I declared up there, num years. And then a semicolon at the end. So that will declare a one-dimensional array of integers of size 26, and it assigns the name strikeout to it. So some other things that I said we're going to figure out, or I'm going to show you how to get, are things like the sum and the average and highs and lows and those types of things. So I'm going to declare variables for all those. So I'm going to name this strikeout total. Okay, strikeout total, like that, with capital T, camel case notation. Strikeout high, that'll be the value. Strikeout low, that'll be the low value. Later on, I'll show you how to find the index of the high and the low, so I'm going to have variables for those. So I'm going to say strikeout high index, like that, and strikeout low index. And then one more, I'm going to find the average. I'm going to go ahead and make that a double. I'll just name that strikeout average, like that. All right, and then you could compile and run that again if you wanted to. Still good. All right, so after we have those things declared, the next thing we should probably do is think about our files and try to get some input coming in. Okay. And so I need to declare and open my files. So that's the next thing I'm going to do here in main. I'll put a comment here, declare and open files. So our input file, we'll put ifstream, and then I'm going to name mine infile. That's usually what I name mine. And then ofstream outfile. So those are the file variable names that I'm going to use. And then we open them. So we say infile.open, and inside of parentheses and double quotes, the actual file name. So this is going to be that file, the input file that we set up. So I named mine Ryan underscore input.txt. And so I'll name my output file, outfile.open. I'll name it Ryan underscore output. .txt. It's a good name. Again, just a reminder, don't use the same name for your input file and your output file. That will, when it opens your output file, it will basically start writing over your input file. And that's not good. So ifstream infile, ofstream outfile, Ryan input.txt for the input file and Ryan output.txt, or whatever you named your input file, right? If you use a different name, you'd want to do that. And then I like to put in this that little code segment that tests the input file to see if it could be opened. Remember how to do that? I say if not, so the exclamation point, if not in file, and then open and close curly bracket, I'll output some kind of message like cout error. Oops. Could not open input file. And then I like to put a return 0 there just to end the program. And so that will let you know very easily whether or not it was able to open your input file, right? So if you get the error message, then that probably means that either that you don't have the name right of your input file there, or your input file is not in the same folder as your source code file, right? So I'm going to test that. So I don't get the error message, right? But if I'd misspelled the name of my input file, I'd get the error message. If you're on a Mac, remember all the stuff you have to do. If you're on a Mac, you might have to put the full path name on there. And hopefully you don't have any spaces in any of your folders or file names, because that'll mess things up too. All right, so get that going, and then we'll get going on the actual program, the actual input. All right, so we've got our file set up. Now we need to start thinking about how to read in some input. So instead of doing it here in main, since we know all about functions now, I want to split this program up into functions. And so they'll also give us some practice on passing parameters into functions, including arrays. We haven't done that before. So I'm going to come down here to after the main function. So here's the end of the main function. So just go after your main function. And we're going to write a function. We'll name it getInput. That's a good name. So here's how you do it. The name of it's a void function. The name of the function will be getInput. And then inside of parentheses, we're going to have our parameter list. Okay? So we need to send in the strikeout array because we're going to be reading stuff into it, right? So here's how you do that. It works a lot like normal. You say int and then strikeout, but since it's a one-dimensional array, you have to put open and close square brackets like that. We also need to send in our input file, and you always pass your files by reference. So the data type for your input file is ifstream, and then an ampersand, and then the name of it, in file. And then open and close curly brackets for the function. So some of you might be thinking, okay, so as far as like, do we pass the strikeout array by value or by reference? How does that work? Because we know now how to pass variables by value or by reference. So here's the deal with arrays. Arrays are always passed by reference. You can't really pass an array by value. And what it does when you pass an array into a function, it actually sends the memory address of the first element. So it sends the memory address of where the array starts, basically in memory. And so arrays are always passed by reference. You don't put any kind of ampersand on an array in the parameter list. Later in the next function, I'll show you how you can put the word const in front of the array name and stuff, in front of the data type when you pass an array, and that it still passes it by reference, but it kind of locks it so that you can't change it. But here we're going to be changing it. We're going to be reading stuff into it, right? When you input, you are changing the array. So that's how you should set up your function there. All right, so we talked about arrays, one-dimensional arrays, and how we can automate stuff with for loops, right? Because obviously we could do something like this. We could read stuff in by just saying like in file into strikeout sub-0, and then in file into strikeout sub-1, and so forth like that. But we'd have to do that like 26 times, right? That would get old really quick. And what if it was some kind of other application and it wasn't just 26? It was like 500. Well, that would be no good. So we can automate this with a loop, okay? And so we're going to set up our loop. And so we're going to need a loop control variable to keep track of where we are in the array. And so I showed you how to do that the other day. So I would set up a variable like index is a good one. So int index. And then set up your loop to go through the array. So it'll look like this: for index is equal to 0, semicolon. So we start index off at 0 because the indexes in the array start at 0. And then index, the test should be index is less than 26 or num years, right? I've got my num years constant up there, and a semicolon, and then index plus plus. It's going up by 1 every time. So there's your loop. And then I'm going to say open and close curly brackets on this one, like that. So every time it goes through the loop, index will be going up by 1, right? So it'll go from 0 to 25, just like the indexes of the array. And so every time we want to go through that, every time we go through the loop, we want to grab one of the strikeouts. And so we can do it like this. We can say in file into strikeout sub index, like that. So every time it goes through, it will grab a value and put it in the strikeout array, in the index, on whatever index position we're talking about. Now this one's a little bit more complicated because if all you had was the strikeouts inside of the input file, this is all you'd have to do. But if you look back on the input file, we've got all this extra stuff in there, right? That we don't care about at this point, right? So we've got, on every line, we've got the win, the loss, the ERA, then the strikeout, and then the team name, right? So we only want to pick up the strikeout numbers. And so we're going to have to write some code to kind of skip over some stuff. And so do you remember back in chapter 3, we had that ignore function? Remember that thing? We can use the ignore function to skip over input. So that's what I'm going to do here. And so I'm going to say, and this is before you pick up the strikeout, we're going to say infile.ignore, and then inside of parentheses, remember it's some number of character spots to ignore, comma, or until it gets to one particular character. What character is in between each input value? Well, there's a space, right? Yeah. So it looked like that. I just chose 10 because I knew that it wouldn't get to that many. You wouldn't want to choose 1 because it could get to the one character before the space. So ignore the next 10 spaces or until you get to a space in the input file, whichever one comes first. Again, it's going to get to the space first. So that will skip over the win, right? They'll skip the win in the input file. And then we need to do the same thing to skip over the loss. So I'm going to do the same thing, infile.ignore 10 or a space, whichever one comes first. The space will come first. So that's going to skip over the loss. Oh, then we've got the ERA, right? So I'm going to do it one more time. infile.ignore. You could have just copied and pasted that line. Later on, when we add arrays for the win, loss, and the ERA, we'll come back and we'll take these lines out and replace them with actual input lines that pick up those values. But for right now, we just want to skip over them. And then there's one other thing. The team name is at the end of the line, right? So I need to skip over that as well. If I don't do that, then it'll do something weird, like try to input the team name into the next strikeout spot. So again, here I'm gonna I'll just do it like this. Where this was inputting strikeout. So I'm going to say infile, and the team name is a little different because it's at the end of the line. So I want to ignore the rest of the line. So instead of checking for the space, I need to check for the new line character, the \n. So it would look like this. And I chose a larger number instead of 10 just in case there were any team names that might be longer than 10 or something. I don't think there are any, but so I'm going to say infile.ignore. And I said 50. And then inside of single quotes, \n. Make sure you're doing backslash and not / on that. Like that. And again, that will skip the team name. And I think that's it, unless there's something I messed up on. So what's so cool about using for loops with arrays is that you do it once inside the for loop, and then you just set the for loop to go through 26 times or however many, whatever the size of the array is. So every time it goes through that loop, it's going to skip over the win, loss, and the ERA, grab the strikeout, put it in that corresponding spot right in the strikeout array, skip over the team name. Next time it does the same thing on the next line. So after you get that, then we need to do the prototype and the call for get input. So does everybody have that? No? Okay. So let's add the prototype and the call. So again, we could just simply copy and paste the heading here for the prototype. That would be the safe thing to do. I'm going to go ahead and type it from scratch because I'm not safe. I don't know. But up here over the function prototypes, before main, we're going to put void, and the name of the function was get input, right? And we said that in the prototypes, you can, as far as the parameter list, you can put names if you want to, but you don't have to, but you have to put everything else. So we can just say int, open and close, square bracket, if we want to. That's the least that we need. And then if stream by reference. So that's my prototype. And that has to match up with what I have down there, right? So I'm passing in an integer, a one-dimensional integer array, and an if stream, input file stream object by reference. That's what I'm sending. So there's your prototype. And then the call, let's see if I can still leave that up there. Oh, I'm not going to be able to. Does everybody get that? When you do the call, you'll just put get input and then send in strikeout and strikeout, and end file. So I'm going to do the call down here after I've checked my input file. In fact, that's where I'll put all my function calls. So we'll say get input, and we send in strikeout, comma, end file. So notice I didn't put the square brackets on the array name. So when you pass an array into a function, in the function call, you don't put any kind of square brackets. You only put names in function calls. All right, so in function calls, you only put names. In the function heading, you put everything. And in the prototype, you can put everything, but you at least have to have everything except names. I'm going to compile that and run it. Right. So I compiled and run, but I don't really know for sure if it worked, right? So I think it probably worked, but before we go on in this program, I'd like to have some kind of assurance that it actually inputted things correctly. And so what I'm going to do, I'm going to put in some code down here after my function calls. It's kind of like temporary code. We'll probably come back and take it out later, or at least comment it out so it doesn't get done. But as we go through, I just like to make sure that things are working. So I'm going to do this after my function call. I'm just going to say this is some temp code. I'll say temp test code. And so I've said that you can't just like simply output the entire array with one line, right? You're not allowed to do that with arrays. So you have to use your handy dandy for loop to do that. And so it'll be just like what we did before. Int index, and then so this is in main after I've called get input, and I'm just going to test it here. So that same good old for loop. In fact, you could just go down there and copy and paste it if you want to. For index is equal to 0, index is less than num years, index plus plus. And actually, I'm just going to output, I'm going to say like cout, strikeout, and then inside of square brackets, index. And then it'd be nice if I have a space in between each number so that all the numbers don't run together like that. And then I'll just put an indel after that for the heck of it. And so when we compile and run it, hopefully we'll get some numbers. Hopefully we'll get the strikeout numbers. So there you go. Those are his strikeouts. So it worked. So it skipped over the wins, the losses, the ERA, picked up the strikeout, and then skipped over the team name. So you should get something like that. So I'll leave that up there, and hopefully everybody's will work. But we'll see. All right, I need to move on to the next thing, or we're not gonna get very far. All right, so let's deal with this finding the total and the average. Okay. So I'm going to come down here. I'm going to write a separate function that's going to handle those responsibilities for me. And so go down. I'm just going to go under get input, and I'm going to add another function. So I'm going to say void. I'll name this one something like calc total average. Okay. And then I'm going to send in some things. I need to send in my strikeout array. But I said that if you put the word const in front, then it will kind of lock it so that it can't be changed. And so that's a good programming practice. It goes back to that principle of least privilege thing that I've talked about. Don't give the power to to change the strikeout function if it doesn't need it. So I'm going to say const int strikeout, open and close square brackets, comma, and then I'm going to send in the strikeout total and the strikeout average. But those are just variables, and I need to pass those by reference so that when I change them down here, it remembers the changes back in main. So the name was strikeout total, like that. That was an int, and then the second one, or the next one, was a double. So double ampersand strikeout average. I'll go down. I'll put that on the next line so you can see it. Like that, and then open and close curly brackets. Calc total average, strikeout, total strikeout average. Okay. All right, so how do we do this? Well, we're going to need our loop, just like we did before. So I'm going to go ahead and declare that index variable. If you think back, whenever we would find the sum of something, we always needed to make sure that the sum started off at 0, right? So I need to do the same thing here. So I'll put a comment here. I'm going to say start totals at 0. Because later on, when we add the other things, we can use the same function to find the total number of wins and the total number of losses and those things too. Start totals at 0, so I'm just going to say strikeout total is equal to 0. Easy enough. And then set up your loop, same exact loop. For index is equal to 0, index is less than num years, index plus plus. But this time, inside of my loop, I want to add to the strikeout total. So that'll look something like this. Strikeout total is equal to itself. Strikeout total plus the current strikeout value that I'm looking at, which is strikeout sub index. So every time it goes through the loop, it's going to be focused on a different value in the strikeout array. And every time it goes through, it's going to add that strikeout value to my total. So my total is going to start at 0, but it's going to grow every time I go through. Right? It's going to keep adding to it. You could have written that a little shorter. You could have said strikeout total plus equal strikeout subindex. Right? That's a shortcut way of writing that. But I like to write it out like this. It's a little, I think it's clearer to see. And then once you find the total, you can find the average, right? I'll just kind of put some comments here. I'll say find totals. After we find the total, we can find the average. Or calculate average, whatever you want to say there. So how do we do that? So we'll just divide the total by 26, or num years, right? Strikeout average is equal to, and if you want to make sure it's doing floating point division and not integer division, you can do that. You could typecast strikeout average, typecast the strikeout total into a double, and then divide by num years. We could typecast that as well if we want to. Averages. So there you go. There's your calc total average function. So that's basically finding the sum and the average of a one-dimensional array, right? Here we're talking about baseball strikeouts, but you could apply the same Same basic algorithm to any kind of one-dimensional array. So get that in there, and then we'll do the prototype and the call for that. Okay, so let's do the prototype for that. So go up to the top, and we'll add the prototype. I'll just put this underneath get input. So it's void. What was the name of the function? Calc total average. Calc total average. Calc total average, like that. And we're sending in. And so if you send it with const in front of there, you need to put it here as well. So const int open and close square bracket is at least what you need. And then int ampersand and then double ampersand. That's the minimum of what you have to have in the prototype. Again, you could just copy and paste the heading and add a semicolon. So there's your prototype. And then we need to add the call. What would the call look like? It'll just be calc total average, send in strikeout, strikeout total, strikeout average. So I'm going to put that down here. So calc total average, I'm sending in strikeout, strikeout total, strikeout average. Mm-hmm. Yeah, I could. That's kind of cool. You can close that. Again, you can just copy and paste if you needed to. So how could we test that to see if it worked? I'll go back in a minute if I need to. So I could add some more code down here to my temporary code. So check this out. You could do something like this. Maybe after you go down a line, I'll put a line that looks like this, something like strikeout total, and a colon, and the actual variable there, strikeout total, and an indel. So let's see what it ended up being, right? So strikeout total was 5,708. That's a lot of strikeouts. And if you look up his career stats, it's actually a few more than that. And those extra ones are from that season that I didn't count. Like maybe the season before his first season, or before the first one that I have. I can't remember. All-time strikeout leaders. So yeah, here you go. So Nolan Ryan is first on the list, 5,714 strikeouts officially. So he had a few more, but what is that? That's not very many more than what we've got. So I didn't include that season because I didn't think it was noteworthy. And then next on the list, is everybody good with this, or do I need to go to a different spot? Next on the list is Randy Johnson. Y'all remember Randy Johnson? Real tall pitcher. He's a left-hander. Threw really hard. Third on the and Randy Johnson was 4,875. So that's like 900 back or something like that, right? That's a big difference there. Roger Clemens is number 3. Y'all remember Roger Clemens? He pitched for number of teams. Roger Clemens pitched for the Red Sox and the Yankees and the Astros. There at the end of it, or after he retired and stuff, he had that steroid controversy thing where they had hearings and Andy Pettit testified, and it was like a big deal. Then you've got some other pitchers that you may not be familiar with, like Steve Carlton, Burt Blyleven, Tom Seaver, Don Sutton, Gaylord Perry. They're all legends as well. Do I need to go up to the prototypes? Okay.
I keep running into an error.
Who else is on the list? Hold on a second. Walter Johnson. Number 10 on the list is Greg Maddux, probably my all-time favorite pitcher. Greg Maddux pitched for the Atlanta Braves most of his career, later for some other teams like maybe the Padres and maybe the Cubs too, I think maybe. Greg Maddux is great because he wasn't like the most powerful pitcher, but he could kill you with his accuracy. Pedro Martinez is 13. Kurt Schilling is 15. John Smoltz, 16. You may see him some on like baseball shows and calling games and stuff. The top current player is CC Sabathia at number 17. 2,986 strikeouts. All right. Yeah. Here's the prototype again. All right, just for the heck of it, let's output the average as well. I forgot to do that. Just on our test code. If your sum is working, if your total is working, the average is probably working as well. So I'll say output strikeout average colon, and then you can go back and add that later. Strikeout average, like that. $219.538 strikeouts. That sounds about right. Let's go ahead and try to do one more here. So let me show you how to find the high and the low values in a one-dimensional array. So I'm going to go down here after my last function, and we'll add another function here. Okay. So this can be a void function. I'll name it find high low value. Okay, that's what I'm going to name it. Find high low value, and I'm going to send in a strikeout array, but just like I did before, I'm going to say const int strikeout, open and close square bracket. And then what did I name it? Strikeout high and strikeout low. Those are the two variables, and they're both integers. And I pass those by reference. So int strikeout high, and int ampersand strikeout low, like that. Okay. So the basic setup is going to be very similar to what we just did, but what we do inside the loop is different. So I'm going to set up my variable int index. And then we need to initialize our highs and lows to something. Okay, so I'm making a comment here. Initialize high and low values. I don't want to initialize them like to 0 because if I did that, my low would probably end up being 0, right? Because I think there was at least one. I think you had at least one strikeout in every year, right? So what I'm going to do, I'm going to initialize my high and low values to the first element in the array. That's how most books show it. So that would look like this. So we'd say strikeout high is equal to, what's the first element? Is strikeout sub 0, right? The index is 0 on the first element. No, I misspelled strikeout, sorry. Strikeout high. And I'm going to do it the same thing on the low. Strikeout low is equal to strikeout sub 0. Okay. So we're going to assume that at the beginning, the highest and the lowest number in the array is the first element. Okay. And then what we're going to do next is we're going to scan through the rest of the array using our loop. And if we find one that's higher than the current high, we're going to update what the high is. And if the one that we're looking at is lower than the current low, we're going to update what the low is. So the loop will be, well, technically, we've been starting index off at 0. We could start it off at 0 if we wanted to, but we don't really need to here because we just initialized the high and the low to the first element in the array. So we could start index off at 1. That would be a little bit more efficient. You could start it off at 0. That would work as well, but it's kind of unnecessary because that first time through the loop, you just be comparing the high and the strikeout and the first strikeout value, which are going to be the same because we just initialize it to the same thing. So we can start it off at 1. So initializing to the first element and then starting with the second element, go through and see if you have one bigger or smaller. So index is less than num years, index plus plus. So I'm going to say open and close curly brackets. So next I'm going to check for a new high value. So how do you do that? Well, we can have an if statement, right? So if the current strikeout value that I'm looking at, which is strikeout sub index, right? If that guy is greater than strikeout high, then I found a new high, new current high, and I need to update what the high is. So the strikeout high is now going to be equal to what? Strikeout index, like that. And do the same thing for the low, right? In fact, you could probably just copy and paste that and modify it a little bit. So if strikeout subindex is less than, make sure you got it, your greater than and less than signs going the right way. Strikeout low If it's less than strikeout low, then now strikeout low is equal to strikeout subindex. Like that. And there's your function. Of course, it doesn't run yet. But so does everybody see what's going on there? Just like this. So we need to hurry so I can finish this one. Oh, where are my numbers? 133. 92. I cannot read that. 125 and 137. 329. 83. Right. What's the last one? 46. 46. I guess he decided to hang it up after that 46 strikeouts. So you've got your array, right? It's hard to read those numbers. But we want to know what the high and the low values are in there, right? So we've got variables for them. Strikeout high, strikeout low, so what's it doing? It's initializing them both to the first element in the strikeout array, which has a value of 133. So they both start off at 133, right, like that, and then it tests it, and it goes through starting with the second one. So is 92 larger than 133? No. So we don't do anything. If we don't need to change anything, then we don't. There's no else on those, right? But is 92 smaller than 133? Yes. So we replace the current low with whatever that is. I'm just going to make a note here. And then the next one is 125. Is 125 bigger than 133? No, and it's not less than 92. Then you go to 137. 137 is bigger, right? So it replaces that. And then the next year, he really turned it on. 329, so it replaces that with 329, right? And so forth, and replaces that with 383. And it keeps going, and it updates the highs and the lows if needed to. That low ends up being 46, I believe. So does everybody see what's going on there? All right, so let's get the prototype and the call. So the prototype, go up there, your prototype list. We're going to say void. The name of that function was find high-low values or something like that, I think. Find high-low value. So we say const int open and close square bracket for our array, and then we're sending two ints by reference. Like that. So it looks pretty much like the one above it, except it's two integers by reference instead of an int and a double. And then do the call. So I'm going to put the call after my calc total average call. So this one is find high-low value. and I'm sending in strikeout, strikeout high, and strikeout low, like that. And then to see if it worked, we can add a couple of lines here on our temp code. It looks like this. So I'm going to say strikeout high value. So strikeout high. And the same thing on the low. Strikeout low value. Low. So there's the strikeout high value, 383, and the low value is 46. So that's what you should get. Sorry, I did that kind of fast. So I'll leave that up there, and can help people. So next time we'll continue with this, and we will. The first thing I'll show you is how to instead of finding the high and the low values, we can keep track of where the index is of the high and the low. And there's some cool little things that you can do with that by keeping track of the indexes instead of the actual values. And then I will show you, what was the other thing? And then we'll output some stuff. Well, we might actually, we'll do that, and then we can take this and expand it. That's probably what we'll do next. So after we get all this stuff working, we'll expand it and add arrays for the win, the number of wins, and the number of losses, the ERA, and the team name. And that'll get us into this concept called parallel arrays, where we have multiple arrays that are related, but they're separate one-dimensional arrays. All right. I'm going to stop this, or at least pause it.